Welcome. This video covers retrieval augmented generation from the ground up. Let's get into it. Every company drowns in documents, HR handbooks, product specs, policy updates, meeting notes that nobody can find 2 weeks later. And when an employee needs a quick answer, they search, they scroll, they ask a colleague who has to search and scroll. Decisions get made on outdated information. Onboarding takes weeks instead of days. Critical knowledge sits locked in files that are technically accessible but practically invisible. AI should be able to fix this, and it can. To show you exactly how, let's walk through a real example. TechVault Inc., a fictional cloud storage company with 287 employees spread across the globe. Like any modern company, TechVault has accumulated a lot of knowledge. Employee handbooks with all their HR policies, detailed product specifications for their cloud storage platform, expense policies and guidelines, and meeting notes from quarterly all hands sessions. Over 1,200 pages of critical company information. This is the data we'll use to show how RAG actually works. Let's make this concrete. Meet Sarah, a marketing employee at TechVault. She has a simple question. What's the company's remote work internet stipend? She asks a standard AI assistant, one of those powerful large language models. The question goes to the LLM, and here's what comes back. The AI says, I don't have information about TechVault's specific policies. Typical companies offer $30 to $75 per month. Completely useless. It knows a lot language, reasoning, general knowledge, just nothing about TechVault. This is the fundamental problem. You might be thinking, I could just find the right document myself and copy the relevant section. Sure. Sarah opens the employee handbook, finds the section about internet stipends, copies the text, pastes it into the chat with her question. The LLM gives the correct answer $50 per month. It works. But think about doing this for every single question, searching through hundreds of documents, finding the right section, copying and pasting over and over. 5 plus minutes per question. Error prone. Copy the wrong section and you get the wrong answer. With 1,200 pages of company knowledge, nobody is doing that for long. This whole process needs to run itself. That's exactly what RAG does. Retrieval Augmented Generation. Three pieces that automate the whole thing. First, your knowledge base, all company documents in one place. Second, a retrieval system that searches those documents automatically. Third, the LLM that generates the answer. Sarah sends her question. It goes to the retrieval system. The system searches the knowledge base. Relevant context plus the question go to the LLM. The LLM answers using TechVault's actual data. The whole thing takes under a second. No copying, no searching, no guessing. But how does the retrieval step actually find the right information? Let's look at that. The simplest approach is keyword search, and the fastest way to understand it is with two questions. Same system, two very different outcomes. Sarah asks, what's the remote work internet stipend? Keywords extracted remote work, internet, stipend. Exact match in the handbook. Internet, $50 per month. Success. Then she asks it differently. How much do I get for my home Wi Fi? Keywords home Wi Fi. The search finds nothing. The document says internet, the question says Wi Fi. Same thing, but keyword search doesn't know that. That's the fundamental limitation. So, how do we solve this? Semantic search with vector databases. Instead of matching keywords, we convert everything into vectors, mathematical representations of meaning. Your documents get broken into chunks. Each chunk becomes a vector, arrays of numbers. The striking part: similar concepts cluster together in this space. Internet, Wi Fi, connectivity, they all land near each other because they mean similar things. Sarah asks, "How much for my home Wi Fi?" The question becomes a vector. The system finds the closest vectors. Even though the document says internet and she said Wi Fi, it retrieves the right answer. Semantic search doesn't match words, it matches meaning. With semantic search, we have a complete system. This is naive RAG. The flow is straightforward. User asks a question. Vector search finds similar chunks. Retrieve the top 5 results, send them to the LLM for an answer. It works. But naive RAG has real limitations. It retrieves noise along with the signal. Some chunks are irrelevant. It can miss context spread across multiple documents. No re ranking. All results treated equally, even when relevance varies. It works well enough for simple use cases. Push it harder and the cracks show. You've now seen naive RAG in action. Same question: what's the internet stipend? Three very different paths to the answer. Level 1: naive RAG. Question goes straight to vector search. Top 5 chunks go to the LLM. Fast, but no intelligence applied anywhere in the pipeline. Level 2: advanced RAG. See what gets added. The question is rewritten first to improve the search. Results come back and get re ranked by relevance. The LLM only sees the best three, a much smarter pipeline. Level 3: Agentic RAG. An AI agent takes charge. Give it a complex question. Compare our PTO policy to the expense reimbursement timeline, and it splits that into two separate searches automatically, then synthesizes the results. The AI decides how to retrieve, not just what to retrieve. All three levels are covered in the series. The right choice depends on your use case, but the impact is real regardless of which you pick. So let's put numbers to it. Before RAG, an employee asks a question. Manually open documents, search through hundreds of pages, copy and paste text. 5 plus minutes per question. Error prone, tedious, falls apart at scale. With RAG, same question. RAG searches, retrieves context, and generates the answer. 5 seconds. 95% faster, accurate from your actual data, fully automated. 60 times faster, zero errors, and it scales to every employee. Everything in this video is the foundation. Here's where the series goes from here. Part 2: Vector Databases. We go under the hood and build a real ChromaDB pipeline in Python. Embed TechVault's documents, store them, run live semantic queries. Part 3: Document Chunking. The step that breaks most RAG systems. Same documents, same database. Different chunking produces completely different retrieval results. Part 4: Advanced RAG. Query rewriting, hide, cross encoder re ranking. The techniques that separate a working system from a good one. Part 5: Agentic RAG. A React agent that decides when and how to search, handling multi hop questions on its own. And part 6: The honest one. When is RAG actually the wrong answer? Graph RAG, fine tuning, hybrid search, and the full decision framework. Each video builds on the last, and the code carries through the whole series. Subscribe so you don't miss it. Thanks for watching. If this was useful, subscribe. The next video goes deep on vector databases, and the code starts there. Find us on social. See you in part 2.